Okay, so we're on our final example here for this lesson and for this series of lessons. We're trying to write a trigonometric function from a graph. So this is kind of where we culminate. We see an image of a wave and we want to say, how can we turn this into math language? How can we turn this into an equation? The applications of that would be like any wave out in nature that we could look at. We should be able to then take it and turn it into a math expression. So let's give it a try with this one. They say this is going to be a cosine graph. Now, there's no difference between cosine and sine graphs. There's no fundamental difference other than they're horizontally shifted from one another. So they could have easily called this a sine graph, um, then call it a cosine graph. They've just kind of decided we're going to use cosine for this one. So what we are going to do, let's take a look at this and let's open up Desmos. And let's see how close we can get this to match. So first of all, let's get our units to look the same. So I'm going to take my scale. We're going to change our y-axis to go up to 6, to go down to -2. X-axis is going to go from -4 pi to 4 pi. And we're going to put this in radians because we're seeing pi's out here. Okay, so that should be good there. We've been told it's a cosine. So let's put cosine of x first. The amplitude appears to have grown, so it's not going from 1 to -1, it's going from 5 to -1. Okay, so rather than having a full stretch of 2, an oscillation of 2, we have an oscillation of 5 to 1, we have an oscillation of 6. We cut that in half for our amplitude, right? So we're going to say 3 cosine of x, and then we are going to raise it up so that we are not going through the 0.3, we're getting up to the 0.5. So it looks like we're going to have to shift upwards by 2. Okay, now let's try to get our period correct. So in my graph, my period is, I think we're looking kind of good already, are we? Let's check. So our period right now, we go down and then we come back up, and the full period is accomplished at 2 pi. Okay, now on theirs, it looks like we go from -3 pi to +pi. So it looks like they're doing a period of 4 pi rather than 2 pi. Okay, so ours needs to be stretched outwards by a factor of 2. We're currently finishing our period after 2 pi, and they want the whole period to finish after 4. So if we want to stretch it by a factor of 2, we want to multiply this thing by 1/2. Our b value should be 1/2. If I can get it there, 1/2. Okay, so now it looks like we go out to 4 pi by the time that one full rotation has been finished. You can get that 1/2 number if you want to play around with this whole relationship of the period being 1 over the frequency, the period being equal to 360 divided by the b value. So if you want to kind of use that formula to get to that number, otherwise you just want to kind of keep in mind, I think what's probably a better thing to keep in mind really is just that when we have a b value that is above 1, that is telling us how much we are compressing by, and if we have a b value that's a fraction, that is telling us how much we are expanding it by. So a fraction of 1/2 actually kind of stretches it out, so every value in the x direction doubles. Okay, so the very last thing here, we just need to shift it. So it looks like we are at 2 pi, we're at 1 pi here. So it looks like we want to go pi to the right, which means we need to say minus pi in here. Now we go through the point pi 5, yes. We go through the point -3 pi and 5, hopefully. -3 pi and 5, we go down through -pi, -1. We go through 3 pi and -1. Yes, looks like everything is where it should be. Okay, and that's kind of it. So in the book, they go through and kind of break that down in a different way, step by step. But in general, you're just looking for those key features, your amplitude, your midline, your period, and your horizontal shift. And that's generally the steps that I would go through. I would try to get the amplitude correct. I would try to adjust the midline after that. I would try to get the period correct, and then adjust the horizontal shift after that. So I tend to want to do my multiplication transformations, the ones that are like stretching or compressing. I do those before I do the shifting. Not totally necessary, but I find that's generally the easiest way to get through. Okay, so that is it for trigonometry for this year. That is not it for the subject. There's a lot more to it, more that you would see in future math classes. But as far as your like kind of first big brush with it this year, that is it. So we kind of established what those trigonometry ratios are, what sine, cosine, tangent mean, how they change as we move around through a cycle, move around along the unit circle, figure out how to graph those outputs as you move along the unit circle to create your standard sine and cosine graphs. And now with today's lesson, today's and yesterday's, kind of figuring out how to transform those graphs from the standard one to any other kind of sine function. Now, like I said, there's a lot more that we could talk about with this subject and that you will see in the future, but we're kind of just laying the main foundations now. So I just want to thank you for going through all these lessons with me and doing your best to pick up on this foundational knowledge on trigonometry. It's a big subject, it's an important subject, and it's a good one to feel comfortable with. So if you're not feeling comfortable yet, I recommend that you go back through the videos and refresh wherever you need to. Otherwise, I look forward to seeing you in whatever lesson I see you in next. All right, have a wonderful day.